Consider the integral of cosine of 3x dx. In this integral, we can kind of see that the inside function of cosine is 3x, a constant times the variable we are integrating with respect to. Here, our outside function is cosine, and the inside function is 3x. Now, since the antiderivative of cosine is sine, our first instinct might be that this should be equal to sine of 3x plus c. Let's check that out real quick. Now, we can validate this guess by taking the derivative of sine of 3x. And when we take the derivative of sine of 3x with respect to x, the chain rule tells us to take the derivative of the outside function, so the derivative of sine is cosine, keep the inside function as it is, and then we multiply by the derivative of the inside function. The inside function is 3x, so we multiply by 3. The derivative of sine of 3x with respect to x is 3 times cosine of 3x. Well, that's not exactly what we started with, right? This has a 3 attached to it, but we only had cosine of 3x when we started, so this is definitely not the correct antiderivative. Our answer is effectively too big by a factor of 3. So what if we adjust it by multiplying our initial guess by 1/3 now? We can check again the derivative with respect to x of 1/3 times sine of 3x is equal to 1/3 times 3 times cosine of 3x. The 3 and the 1/3 will cancel out and we're just left with cosine of 3x. Perfect, we found our answer, right? Since the derivative with respect to x of 1/3 sine of 3x is equal to cosine of 3x, we then know that the integral of cosine of 3x dx is going to be equal to 1/3 sine of 3x plus c. Now we're trying to work towards a pattern here, but before we talk about the pattern, now let's do this integration by doing U-Substitution. Starting with our integral of cosine of 3x dx, we normally let the inside of our function be equal to u, so the inside of our function is 3x, so let's let u equal 3x here. Then if we take the derivative with respect to x of u equals 3x, we get du over dx equals 3. We multiply by dx on both sides and we get du equals 3 dx. Now we can't really substitute du in here, right? Because we don't have 3 dx sitting within our integral. But we do have dx, so if we isolate dx here by dividing by 3, we get du over 3 equals dx. We then can substitute du over 3 in for dx. This is where that 1/3 comes from. The integral when we do this U-substitution now is going to be cosine of u. We replace 3x with u, and then we replace dx with 1/3 du. We can bring that 1/3 out front, and we get 1/3 times the integral of cosine u du. Now, the antiderivative of cosine is sine, and so we get 1/3 of sine of u plus c for our integral. To get our final answer, we replace u with 3x. So let's take a moment here and just talk about this rule that we've kind of shown 2 different ways. When the inside is a linear expression like k times x, with k not equal to 0, and there are no extra x factors on the outside of our function, we then take the outside antiderivative, keep the inside expression the same, and divide by k. So the integral of e to the 5x power dx becomes 1/5 times e to the 5x power plus c. Because in the chain rule, when we're doing differentiation, we'd be multiplying by 5. So when we're taking the antiderivative, we are going to be dividing by 5, going the other direction. Similarly, the integral of sine of 4x dx is going to be equal to negative 1/4 cosine of 4x plus c. Because the antiderivative of sine is negative cosine, we keep the 4x as is, and we divide by the constant multiplied by our variable. This is why U-substitution is often called the reverse chain rule. Here, every time you're dividing by that constant when you're doing the antiderivative, you're undoing the extra factor the chain rule would have created coming in the other direction. If you found this video helpful, consider subscribing, commenting, or liking the video to support the channel. I'm Joe, and thanks for spending some time with me.